assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Let's first start by writing the electron configuration for the neutral atom, because that's going to help us write the electron configuration for the ion that was formed. So let's start with radium. Radium is in the 7th row on the periodic table. It's in the 2nd column. This area right here is going to be the s orbital region. So the first thing that we do when we write an electron configuration is we look for the noble gas that precedes the element we're looking at. So in this case, it's going to be radon. Radon is then going to be used in our electron configuration by putting it in brackets. And what this means is that up until this point where radon is on the periodic table, radium has the exact same electron configuration. And then after the brackets, we write in all of the orbitals that radon does not have. So that's going to be anything that comes after radon. So it's going to be the s orbital that radium has in the 7th energy level. And since it's in the 2nd column of the s orbital region, we know it has 2 electrons that occupy that orbital. So now that we have the complete electron configuration for our neutral atom, let's turn it into the electron configuration for the ion. So as we can see, we have a positive 2 charge, which means that we lost 2 electrons. So if we remove 2 electrons from this electron configuration, we can take them out from the s orbital, because that's the farthest from an octet. So the valence electrons are the easiest to remove. And that leaves us with just the noble gas configuration that we had before for radon. And that's actually going to be our final answer, because once those 2 electrons are lost, radium has the same number of electrons as radon has. So its electron configuration can be abbreviated using noble gas. So let's do the same thing for Y. So Y is in the 5th row. It's a transition metal. The transition metals have d orbitals. And it's in the 1st column of the transition metal area. So let's look for the preceding noble gas, which is krypton. Let's write that in brackets, krypton. So now we look for the orbitals that krypton doesn't have, that Y does have. So first we write 5s. And since Y comes after the s orbital region, we know that that s orbital is complete. We know it has 2 electrons. Now we're going to write in the d orbital. As a reminder, when you're writing the energy level for the outermost d level, it's going to be the energy level of the row number minus 1. So since Y is in row number 5, minus 1 is going to be 4. That's the energy level for the d orbital, the outermost d orbital. It's in the 1st column in the d orbital region, so it has 1 electron here. So as you can see, we have 2 electrons, 1 electron. We have 3 electrons in element Y that krypton does not have. So they're not in a complete octet. So again, we turn our electron configuration for the neutral into the electron configuration for the ion by looking at the charge. And we see that since it has a +3 charge, that means we lost 3 electrons. So if we remove the 3 outer electrons that I mentioned before, since these are the easiest to remove, we end up having the same number of electrons as krypton. So we can write our electron configuration abbreviated like this, krypton in brackets. So the same thing for titanium. So titanium is also a transition metal. It's in the fourth row. It's in the second column of the d orbital region, the fourth column overall in the periodic table. So let's look for its preceding noble gas, which is argon, and write that in brackets. Now we fill in all the orbitals that argon does not have to write the electron configuration for the neutral titanium. So that's going to be 4s, and we know that's complete. And then 3d, and since it's in the second column, we know it has 2 electrons occupying the d orbital. And again, we look at the charge, we see it's a +4 charge, so we know that we lost 4 electrons. So we get rid of the 4 outermost electrons, and we're left with just the noble gas configuration. That can be our final answer. And finally, let's look at nitrogen. Nitrogen is in the p orbital region. It's in the third column of this region. And its preceding noble gas is helium. So we can write helium in brackets. We fill in all of the orbitals that helium does not have that nitrogen does have. So that's anything that comes after helium. It's 2s. We know that's complete. The second row doesn't have a d orbital. So then we write the p orbital, and that has the same energy level as the row number. And again, nitrogen is in the third column in the p area, so we know it has 3 electrons. So now we look at the charge of the ion to change our electron configuration for the neutral nitrogen so that it matches for the ion. So since it's -3, that means we gained 3 electrons. We're going to add these 3 electrons to the most empty orbital. So 3 plus 3 is going to be 6. So this is our new electron configuration. Technically this is correct, but we can also rewrite this as the abbreviated noble gas configuration of neon, because it has the exact same number of electrons as neon. And this will be our final answer.